One of the important topic in control systems is the polar plot. We will discuss about in detail about the polar plot. So this polar plot has two axes. One is a real axis which is represented by sigma. One is imaginary axis which is represented by j omega. So it is something like x plus jy form. Okay, so in this real and imaginary axis, this has also subdivided into the angles 0 degrees, 90 degrees, 180 degrees, 270 and 360 if you go in a counterclockwise direction. Whereas if you go in clockwise direction, it will become 0, 90, -90, -180 and -270 degrees centigrade and -360. This is how we have to represent. So let us take one simple example and then try to see how it is moving. Let us take an example of 10 at an angle of -45 degrees. In the 10 at angle of -45, so I will draw the both the which is Cartesian polar form, which is having both the real axis and the imaginary axis. So I am representing my angles as 0 degrees, -90 degrees, -180, -270 and -360. Now I want to represent -45. -45 is in lies between my 0 and -90. So I am drawing that, and it is having a magnitude of 10. So I want to draw 10 magnitude at an angle of -45 degrees. That is how you can represent in a simple Cartesian form 10 magnitude having an angle of 45 degrees. So if it is same thing, if I take one more example of 10 at an angle of -145, so which will be coming into the third quadrant. Okay, so you can see again. I am just taking into with different color here. You can see after till this is 90 degrees. Okay, after 45 if you take 90 plus 45, that will become total 135 degrees, 135. But what we need is 145. So we have to add 10 more degrees to the 135 so that we can achieve the 145. So but this is also having the same magnitude 10 10 at an angle of 145 degrees. So the same thing that we can extend from there to here, so you will get 10 at an angle of -145 degrees centigrade. So that is how we can easily draw both the magnitude as well as angle in a single Cartesian form, in a single polar form, where we have the both the real axis and the imaginary axis. Now let us take one. Let us continue this discussion in terms of transfer function model. Let us take an example of the transfer function model. G of s is equal to 1 by 1 plus 1 plus s. So g of s is equal to 1 by 1 plus s. So it is having both the magnitude. We have to draw both the magnitude and the phase. So here important thing, s is equal to j omega. It is something like that x plus iy form. So 1 by 1 plus j omega. So it is, if you want to find out the magnitude of x plus iy, you obviously do square root of x square plus y square. And if you want to find out the angle, obviously you have to, whenever it is in the numerator, it will be tan. Whenever it is in the denominator, tan inverse. Whenever it is in the denominator, minus tan inverse. So now let us take both the magnitude and angle, and for omega is equal to 0, substituting the value of omega here, 1 by square root of 1 plus omega square, so 1 by square root of 1 plus 0 square, that is 1 by root 1 into 1. Same thing here, angle is tan inverse of minus tan inverse of 0 by 1, so minus tan inverse of 0 minus that is 0 degrees. So at infinity, 1 by 1 plus square root of infinity square under root we have to draw. Okay, because whenever we are trying to draw with the infinity, obviously 1 by infinity into infinity plus anything is infinity. So obviously it will 1 by infinity will become equal to 0. So that means the magnitude at infinity is equal to 0. The same way, minus tan inverse of infinity is 9. Tan inverse of infinity will occur 90 degrees. So minus into 90 is minus 90 degrees. So now we have both the frequency, omega, magnitude and phase. At omega is equal to 0, magnitude is 1, phase is 0. At omega is equal to infinity, magnitude is 0, phase is minus 90. So we'll draw both of them in a R plot. So here it is 0 degrees, 90 degrees and 180 degrees, 270, and then it is 360 degrees. So what we need is, at 0 magnitude is 1 and phase is 0 degrees. At infinity the magnitude is 0 and the phase is minus 90 degrees. So that I have to represent carefully on the x axis and y axis. So I am representing 1 at angle 0, and now at infinity it is going to minus 90. So it is always moving in a semicircular fashion. And it is moving at minus 90, and it is having magnitude 0. So that is what I have written. Magnitude 0 and minus 90 degrees. That is how it is moving. So that is how the polar plot should be drawn for this simple transfer function. The same thing can be extended to one more example. So let us take a little different example from this so that we will learn more understanding into that. So g of s is equal to 1 by s square into 1 plus s. This is most important. Here I have written 1 by s square. We know already that. So if s is equal to j omega, that means that is equal to 90 degrees. Okay. If s is 1 by s is equal to 1 by j omega, that is equal to minus 90 degrees. So when we are representing 1 by s square, it is minus 180. Okay. You have to, because s square it is minus 180 degrees. So now for changing the value of omega, we will draw both the magnitude and the phase. The magnitude is square root of omega square whole square under root. So generally j we have to discard, okay? 1 square root of j omega whole square. Okay, x plus iy can be trans square root of x square plus y square. No, you can discard the value of j and you can directly write that. So here angle is minus 180 minus tan inverse of omega by 1. So that tan inverse of omega by 1 is omega. So now let us substitute the value of omega as 0. So by substituting the value of omega as 0, 0 into anything is 0. So 1 by 0 is infinity. So whereas minus 180 minus tan inverse of 0, tan inverse of 0 is 0, minus 180 minus 0 is minus 180 degrees. So now we have got both the values of for both the values of omega is equal to 0 and omega is equal to infinity. So I mean at omega is equal to 0 we got all the values. Now omega is equal to infinity, we will substitute 1 by infinity, anything is 0, and minus 180 minus tan inverse of infinity. Tan is infinity whenever it is 90 degrees. So minus 180 minus 90, that is minus 270. Now we have got both the values at omega is equal to 0 and at omega is equal to infinity. Now we will draw the same polar plot in xy axis as we have seen. So now let us list down what is the value of omega at 0 magnitude and phase, and at infinity what is the magnitude and phase. After that let us draw the Cartesian form here, I mean polar form here. So now here it is 0 degrees, 90 degrees, minus 90, minus 180, minus 270, minus 360. So now you observe carefully, at omega is equal to 0 it is having my infinite magnitude and it is of minus 180 degrees. So okay, minus 180 degrees it is having infinite magnitude. And how it is traveling? It is traveling toward 0 magnitude and having minus 270 degrees. So where is minus 270? That will start and that will end up here. So that is how we have to write, very simple, when omega is equal to 0 and when omega is equal to infinity. So this is the simplest way to represent the polar plot. So let us take further more understanding into deeper. Let us take one more example, that is 1 by s square into 1 plus s into 1 plus 2s. That is same thing again and again. Okay, so we will draw the same again by substituting value of omega. We have to find out the magnitude in the phase. So directly we'll write. Okay, now because since we have already have little experience, we can directly 1 by 0 into anything is 0. So 1 by 0 is infinity directly. So and angle s square is there, so minus 180. So 1 plus is there, minus tan inverse of omega. 1 plus 2s is minus tan inverse of 2 omega. Substituting omega is equal to 0, so always all values is 0. 180 minus 0, 0, minus 180. So similarly, when omega is equal to infinity, 1 by infinity is 0, so obviously we will get 0 magnitude minus 180, and tan inverse of infinity is getting at 90 degrees, minus 180 minus 90 minus 90, minus 180 minus 180 minus 360 degrees. Now we have got both the magnitude as well as phase at omega is equal to 0 and omega is equal to infinity. So now let us draw our polar form and we'll write our we'll draw the characteristics. At omega is equal to 0, infinite magnitude at minus 180, and whereas at omega is equal to infinity, 0 magnitude is minus 360, so it will go to towards 360. That is that much simple it is. Wherever it is 360 is there, it will go like this. So the arrow will go in this direction. Let us solve one more example of which is having 0. So right now we have drawn only with the poles. Now if we are having 0, what is the situation that we are going to face? Let us take same thing, 1 by s square into 1 plus s into 1 plus 2s, but which is having a pole of 1 plus 4s. Now we will write both the magnitude and the phase for the same thing. So we'll write the magnitude as 1 plus 4s, 1 is 1 plus 4 omega. So okay, 4j omega. So that is 1 square plus 4j omega square under root. So it is s square whole square under root into square root of 1 plus s square under root plus 1 plus 2s whole square under root. So it's like this, we can easily find everything. And for magnitude, phi is equal to, you can take, so that is minus 180, because it is s square is there, that is minus 180 minus tan inverse of omega by 1 minus tan inverse of 2 omega by 1. So whenever there is a numerator, we have to add the angle, that is tan inverse of 4 omega by 1. So by denominator by 1 we are discarding, so simultaneously we are writing. So now here, if you see, when you substitute omega is equal to 0, so numerator is a finite value, but denominator is 0, so obviously you will get infinity. When phi is equal to 0, so remaining all terms will become equal to 0, you will get minus 180 degrees. That's it, right? So now let us substitute omega is equal to infinity. When we substitute omega is equal to infinity, so numerator is 1 infinity, denominator is 3 times of infinity, so denominator infinity is more than, so 1 by infinity square, approximately it is infinity, so that will become equal to 0. And whereas in the phi it is 180 minus 90 minus 90 plus 90. So 1 plus 91 minus 90 cancel out, that will be minus 270. Now you can see very importantly and closely, you have at omega is equal to 0, magnitude is infinity and phi angle is 180. And at omega is equal to infinity, magnitude is 0 and phi is minus 270. So as per our earlier discussion, it has to start somewhere here and it has to end at minus 270, something like this. So but here is the catch point, that is incorrect. Why? Because there is a 0 on the numerator. So how do we represent the 0? So whenever there is a 0 that is available in the numerator, it has to cut the negative real axis. Whenever it cut the negative real axis, that magnitude will be, that phase angle will be equal to minus 180. From there you can find out the magnitude, and remaining all this information you can easily find out with the help of when you equate the phase angle to be minus 180. So now let us take that phase minus 180 minus tan inverse of omega minus tan inverse of 2 omega plus tan inverse of 4 omega. It is cutting at the negative real axis at minus 180. So this 180 and that 180 will cancel out, and it will get tan inverse of omega is equal to tan inverse of 4 omega is equal to tan inverse of omega plus tan inverse of 2 omega. It is in the form of tan inverse of A plus tan inverse of B. So applying both sides on the tan will out. So 4 omega is equal to A plus B by 1 minus AB. So that is omega plus 2 omega by 1 minus omega into 2 omega. So now if you solve for the omega, 4 omega is equal to 3 omega divided by 1 minus 2 omega square. So you have to find out what is the value of omega where it is getting actually cutting at the negative real axis. So that is called phase crossover frequency, that is represented as 1 by root radians per second. So obviously you can find the magnitude and you can easily draw. So you can have all the details now. At omega is equal to 0, that is minus 180, okay, and it is going towards 270. So now it will cut the negative real axis. So it has to travel from minus 180 to 270 by cutting the real axis. Obviously it has to go in the third quadrant, cutting towards the second quadrant if you take into normal quadrant variations. So having those magnitude and the phase, let us draw that, and easily you can go like this. Yes, now it is very simple. Now you can even easily find out what is the value of omega there and what is the magnitude that is also occurring here. That can be easily find out by substituting the value of omega directly into the magnitude plot. You can easily find out that. So the magnitude is g of j omega is equal to, at omega is equal to square root of 1 by root 8. Okay, you can note it as square root of 1 plus 4 by root 8 whole square into square root of 1 plus 2 by root 8 whole square into 1 plus 2 by root 8 whole square. So from here you can find out what is the magnitude also at omega is equal to 1 by square root of 8. So you will get approximately 10.6, that you can calculate. Now let us solve one more different type of problem, so that we can deeply look into the polar plot different various problems. G of s is equal to s plus 2 by s plus 1 into s minus 1. Now here you can find out for a different value of omega, you can find out the magnitude and the phase. Okay. So magnitude is square root of s square plus 2 square. Okay, that also you can write down. But here important thing is in the denominator there is a minus 1 symbol, right? That minus 1, if you take in the, there is a minus is coming, that you can directly take as minus 180. That is obviously as simple as that. Okay, so magnitude you can directly write s plus 1 x plus iy as root of x square plus y square. So x minus iy also root of x square plus y square. Only the problem will come when you take the phase into consideration. Okay, in the denominator you can see in the numerator tan inverse of omega by 2. So omega by 2 is 0.5. So in the denominator tan inverse of omega into tan inverse of omega by minus 1. So the minus will come, no, minus tan inverse of omega. When it is going to plus on the top, it will become plus tan inverse. Okay, so that minus value I can take as 180 degrees, minus 180 degrees. Whenever there is a minus symbol is coming, that means in actual direction we are going anti-clockwise, whenever we are going in reverse direction, it will be anti-clockwise direction. Okay, so that one we are tying as minus 180 plus tan inverse of 0.5 omega. Okay, so now we'll see this one into much more clear in one more step. I will take one more example as a understanding for clearing if you have any confusions in the minus uses of the minus symbol. So we'll find out both the magnitude and angle. So as it is the same earlier process whatever you have followed, we found that at omega is equal to 0, magnitude is 2 and angle is minus 180. It is very clear. At omega is equal to infinity, magnitude is 0, angle is minus 90. So it is start from minus 180, it will go to minus 90. So that is how you can write these equations very clearly. Okay. One more example we'll take for further understanding into deep. G of s is equal to s plus 2 divided by s plus 1 into s minus 4. So okay. So here see, if in case if you are getting confused, see generally s plus 1 I am take tan inverse of omega by 1. Similarly s plus 2 tan inverse of omega by 2. If you are getting confused that way, you can compute into 1 plus form. That is, when you take 2 as a common, this will become s by 2 plus 1. If you take in the down 4 as a common, it will become s by 4 minus 1. So 2 ones 2 2s. So s by 4 1 by 2 is 0.5. So s by 2 1 plus form, 1 plus s. Then here it is minus 1 you have to take common. So then it is in the form of 1 plus of minus, that is 1 minus s by 4, that is 0.25 into s. You can write that even that way. Okay, or you can write directly 1 by s by 4. So that minus 1 symbol is there. Minus 1, whenever the symbol is coming, as I told you, you have to go for minus 180. That is obviously when you are finding out the magnitude, you have to find out that minus 180 as a point of interest. That is equal to minus 0.5 into 1 plus 0.5 into s by 1 plus s into 1 minus 0.25 into s. Okay, that is equal to minus 0.5 into 1 plus 0.s 5 j omega by 1 plus j omega into 1 minus 0.25 j omega. Now we will take both the magnitude and phase by using the same value. It's very simple. So g of j omega is equal to, okay, that will go out. Okay, so we'll note down that 0.5 whole square root will go 1 plus 0.5 whole square, 0.5 omega whole square by 1 plus square root of 1 plus omega square into square root of 1 plus 0.25 omega whole square. That is the magnitude. Only the confusion most of you get is at the face. So phase angle phi is equal to minus 180 plus tan inverse of 0.5 omega by 1 minus tan inverse of omega by 1. So now it is going to plus, right? Plus tan inverse of 0.25 omega. So now we can get very things very clear. That is, those things will be clear. So that is, at omega is equal to 0, 0.5, 1 plus 0 divided by 1 plus 0. So obviously you will get 0.5 at omega is equal to 0 as the magnitude. And whereas phi minus 180 plus rest L, everything is 0. So they will get minus 180 only. That is equal to minus 180. Okay. So now at omega is equal to infinity. So infinity by infinity into infinity, right? So denominator is more infinity, right? So that means obviously 1 by denominator more infinity is there. So you'll get 0. And here phi is equal to minus 180 plus tan inverse of infinity is 90 plus 90 minus 90 plus 90. 1 plus 90, 1 minus 90 will goes off. So you will finally arrive at a point of minus 90 only. So you got both the magnitude and angle here. So it will be obviously easy to draw both the magnitude and obviously draw the polar plot. Okay. So here there is 0 exists, right, again in the numerator, so you cannot directly draw. So whenever the 0 exists, the phase we must equate it to minus 180 because it has to cut. So first of all, let us write our the phase equation. Minus 180 plus tan inverse of 0 omega plus tan inverse of 2.25 omega minus tan inverse of omega is equal to minus 180. This 180, that 180, and the left hand side, right hand side will cancels. So tan inverse of omega is equal to tan inverse of 0.5 omega plus tan inverse of 0.25 omega. It is also in the same form whatever we have discussed earlier. Tan inverse of a plus tan inverse of b, applying both sides in the tan, it is will be a plus b by 1 minus ab. So omega is equal to 0.5 plus 0.25 omega divided by 1 minus 0.5 omega into 0.25 omega. So if you substitute, you will get finally value as omega phase crossover frequency is root 2. So by substituting the root 2 value again, okay, by substituting the root 2 value again, how much amount of phase, what is there and what is its magnitude, all those information one can easily obtain. So for phase minus 180 and magnitude is 0.33. How do I get the magnitude 0.33? Let us calculate this. Okay. So at omega is equal to root 2, 0.5 plus 0.5 into root 2 whole square divided by square root of 1 plus root 2 whole square into square root of 1 plus root 2 whole square, root 0.25 into root 2 whole square. So you will get 0.33. That 3.3, these are equal to each other. So now we will draw both the things. So it is starting at here. So it is having magnitude of 0.5 starting at minus 180, and it is going down, and it is at omega is equal to, it is cutting to the negative real axis having magnitude of 0.33, and it is coming back. So that is how we can draw the polar plot very easily from omega is equal to 0 to omega is equal to infinity.